Hello everyone, and welcome to this quick demo of a new feature we're releasing with NetOrca, one that I'm personally quite excited about, especially due to the technology involved, and that's the NetOrca Pack. And NetOrca Pack is an agentic AI config generation, verification, and testing layer that sits on top of NetOrca and really makes use of the LLMs that are being deployed within enterprise at the moment. So it's leveraging on the NetOrca system that we've used to already automate tens of thousands of changes for customers and enabling those customers to safely add AI at any stage to further save time in the automation process. So what it is an add-on. For each customer intent or for each NetOrca service item, it allows you to have separate sections that can generate config, verify that config, and get some results for that. And each of those can independently call an LLM via an API. And the reason we do that is because it works best with enterprise who are building and deploying their own LLM models within the enterprise and normally offering up API calls. This is much easier to get running rather than us offering a custom LLM or something like that. So it's all fully flexible. You don't need to use all of those instances. You could just generate config. You just verify config. It's up to you. And then more importantly, or most importantly, within this, we can also create a self-healing loop, which the AI can then use to fix config or fix any test errors that it may have. And that's all supported and managed within NetOrca. And as with everything we do, it's all about making automation easy and practical and getting it out there. And finally, it leverages all the auditability, all the customer intent matching infrastructure state that comes as part of NetOrca. So in our demo today, we're going to do something quite complex. We're going to have the scenario that it's like a web team. They want to offer a web server off to the rest of the enterprise. So they have a couple of servers there on the right, and they're not running Nginx or anything yet. So we'll configure Nginx for them. Then in the middle layer, they have like a infrastructure load balancer, like an F5, where they'll need to put a VIP between the two web servers. And then finally, they have a firewall layer, which we're going to use a Palo Alto firewall there, which is just going to allow traffic from the clients. And we have two test clients here, which we can show which one gets access. So the process here is that the customer will request as normal. A service item will be created, change instance, and then the configured NetOrca pack will be triggered. And then each of these layers is then individually triggered. So one config layer goes off, and you'll notice that these models that we're triggering here, we're using OpenAI for both, but they're independent. So we're triggering O1 for the config, and we're triggering O3 mini to do the verification layer. So the independence is very important there. And then finally, the results, we won't trigger a model, but what we'll do is have a Python script that goes in and grabs the created config, pushes to each of the devices, and then either comes back and says that everything's good and it can be completed, or it'll re-trigger the loop, put something in results like an error message, re-trigger the loop, and that'll go off and try and fix itself. So we'll see that in action. So before we do anything, I'll just show you that we'll go to our client terminals here. I'll show you that we can't curl to the VIP that's going to be created, which is going to be 51. So that there's no access there on client 1 or client 2. I'll also show you that in our Palo Alto that sits in the middle, we don't have any firewall rules. And in our F5, it's all been cleared out. So there's nothing going on there. So everything that comes from here will be configured. So we're on NetOrca as the Echo team now, and what we're going to do is go into our submission builder. We'll add a new pack pattern, and we'll call it Echo Pack 3. And then as part of this pattern, the pattern that's offered is we need to enter in the web servers. It's 49153. And we'll say one of those web servers, let's just say it's Nginx, should be configured on port 80. So the other one, we will, something different, we'll configure that on 8080. And we'll put the VIP port in as 80. We'll define the health check path to be /health here. And then our allowed networks, we're going to do 31120 71, which is only the client one if we go back here. So we're only going to allow client one to access this. Then we'll validate as normal and we will submit, and we should see as normal that a NetOrca change instance has been created and gone into the process. So now what we're going to do is swap to the networks team. We'll look at the change instances and we'll see that there is one EchoPack 3 that's in there. If we look at the service item there, we'll see that there's a new tab called AI process. And there's our config, verify, and results layers there. Now the config layer has been triggering and it's going off and it's sent the API call to the LLM and it's generating the config. Now just to show you how this is configured, the service owners can configure the LLM at each stage, or optionally they can not configure it if they want to do it themselves. And here they choose the service that it applies to, the stage, config, verify, results, the LLM models. So they can use multiple, we've got a lot of different OpenAI ones here, but that can be Claude or anything. And then they put in a big prompt. And, at the base level, this prompt says you're a config generator. You need to generate config for each of these elements. And then we also allow them to put in a JSON schema, which then specifically defines that you should generate an Nginx config. You should put it in that Nginx config heading. Same with F5, same with Palo Alto. And this is what we can leverage to actually use the script to go and execute those things. So we're in EchoPack 3. We have seen the configs now being generated. So we've got our Nginx config for Web Server 1, Web Server 2. We've got full AS3 config generated there. And we've got Palo Alto XML config generated. So importantly, this is just the raw config. This is what goes in the Nginx file. This is what goes to the AS3 API. And this is what goes to the Palo Alto API. We're not doing anything or any abstractions above that. And on the verify layer, the prompt is much similar on the verify layer, but it says you're going to receive these configs. Just check them and tell us if it's valid, true or false, and then give us a result there. And this importantly is the independent step to say, is that config correct? Should I send it to the network? So that all looks good. So what we'll do is run our sync script here. And our sync script here will just get the config from those, get the changes, and it will try and push it to F5. If it fails, it'll get a result. It'll try to push it to Nginx. And if it fails, it will put any results back in. So amazingly, it's all worked. So if we go back in here, we go to results, we've got a full pass here, everything is all good. If we go to our Palo Alto, refresh, and our F5 and refresh that as well, might take a little bit of time, we will see the EchoPack 3 has been created. We've got a VIP here that's been created. We've got pools that are in service. The members are both up. We've got 80, 80, 80. Both of those are up. In our Palo Alto, we've got a rule from 71 to 51, which is the IP address that's been allocated for the VIP there. And basically what we should see now is that a curl from my client 1 on the left here works. It does. And a curl from my client 2 on the right does not work. And this one should work all day and go through the 2 web servers. Beautiful. Now, finally, importantly, we want to go back to the customer and show them that the change has been completed. So it was completed, all good, 2 minutes ago. Now, one of the things with AI is it sometimes works, sometimes doesn't work. So let's try and break it. What I'm going to do is I'm going to make this 443, which will force it to use a certificate. And then I'm going to put health 1 in there. And what we're going to do is submit this as echo, and we're going to create a modify change, which will kick off the AI config creation process as well, again. So we've modified 443, health 1, off we go. So if I go to my networks again, service items, EchoPack 3, we are off and running. We're regenerating the config here. So we will pause and wait till that goes through. So this is regen now. We can see that we're using service HTTPS and we're using TLS servers and the default certs and keys here. And we should also see that it's moved to service HTTPS and the Palo Alto rules. So yeah, this has changed now. Verify has gone, but we've seen a error that's been picked up by Verify here. So this is a really good indicator. So it said the Nginx config health check path, the requested path is health 1, but we're using health. So we have a couple of options here. If I run my script again, it will just re-trigger the loop. But I could also, as a service owner, I have the ability to re-trigger it here. And I can put a comment. I could put in health path is incorrect on Nginx config. And this is all going to go as context to the LLM to go and fix up the config. So that's re-triggered now. Config is going to go away and we'll see what it comes back with. Okay, that re-trigger loop's been round. We can see the location on Nginx is now health 1, which looks good. It's also on the F5 health. Verify is just going through now. Should go pretty quickly. And we should be good to go. So if we refresh that, true, all good. All right, so we go to our sync. We run our sync script again. And it's check that verify layer. It's pushing it to F5 AS3. And hopefully that works. I actually would like to get an error here. Yeah, okay. So we've got an error with Nginx, which is good. So we've gone through the verify layer. We've gone to Nginx. And if we refresh this results, what my script has then done and said, okay, Nginx has a config error. So I want to re-trigger. I'm sending back a result failed. And this is kind of custom here. The beauty of LLMs is you don't need to be real strict what you send back. So what we're actually just sending back is the raw log from Nginx saying that's what's failed. We've re-triggered the config. That's passed now. I think it's asking about events. And you can see the config's got events in it now. So that verify will go again. And we will try and push again. So our verify is good. So we'll go to sync and we will push it again. Now, it's pretty impressive that it's doing all these changes basically in one shot, especially the F5 AS3. I find that config is very complicated. So we've got everything done. So on the fly, this should work. And it does, HTTPS, which is amazing. So we go to the F5 and the PA, and we see all those changes in place. This should now be HTTPS VIP. So we go to VIPs here. We've got HTTPS, we've got the redirect in there. When the PA is a bit slow to reload, when that comes up, we've got service HTTPS. And, you know, we're all proven. We've got this working, we've got this not working. So I hope that gives you a demo of the power of this. To me, it's incredible how well these models work in terms of coming up with the config there. And the scalability of this, or the time you can save by taking what is very complex config. This AS3 we've worked with a long time is very complicated. Taking this and pushing it towards an LLM. And as long as you're within scoped bounds, you can't really do anything wrong with that. So, you know, one of the things we're pushing here is we're only pushing the F5 tenant. On the Palo Alto, we're pushing a unique rule name which is associated with the service item. And the Nginx is contained to the servers themselves. The independent verification layer is really important as well. Using separate complete models for that just adds that check step. And yeah, to me, it's the future. So I hope you enjoyed the demo and get in contact with us if you'd like to see something more.